In this series, I'm going to be tackling the NeetCode 150 bank of programming questions. If you haven't heard of the NeetCode 150, it is 150 hand-picked LeetCode questions. I'm sure a lot of you have heard of LeetCode, and the only difference between that and NeetCode is a former Google engineer picked the 150 questions from LeetCode that he thought gave the best overall understanding of the data structures and algorithms knowledge that interviewees needed going into their tech interviews. And so by going through the NeetCode 150, in theory, one should learn almost everything that they need to prepare for their FANG interviews, or really their software engineering interviews at any company. So my rules for myself for this challenge are pretty simple. I'm going to go through every single one of the 150 problems in the set. I don't know exactly what order I'm going to do them yet. I'm thinking I'll just go through and do every single easy problem first, regardless of which category it falls under, then move on to medium, and then do hard at the end. But that might change. We'll see as I get into it. And I will be filming my first attempt. So I've never seen any of these questions before. I've used LeetCode before, but I don't know if any of the problems I've solved will fall into the NeetCode set or not. But the reason I'm doing this is simply to prep for potentially software engineering interviews in the future. I've worked as a software engineer before, but it's been a while since I've brushed up on my data structures and algs knowledge. So I thought this would be a great way for me to relearn it, and I figured I'd film it all. So here I am on the NeetCode homepage. This is at neetcode.io if you want to follow along. And if I scroll up here, let's look at the roadmap, which shows everything that I'm going to be learning as I go through this entire challenge, which they call the algorithms roadmap. It starts out with arrays and hashing. We move into pointers, the stack data structure. We go into a first searching algorithm, binary search, the sliding window technique, linked lists, all the way down. It looks like the lowest node, and it's cool that this is actually depicting a tree as well. Math and geometry is one of the last things we get to. But yeah, anyway, this is what we're going to be working through, and I can also get to this by going to the practice tab, NeetCode 150 here. And then we're just going to go through the entire list, and I'm going to solve every single one of these to get myself prepared again for programming interviews and to brush up on my algorithm skills. So we're going to start with the very first one today, which is the contains duplicate problem. So I'll open that up. And we see the problem here on the left and a solution or a code editor on the right here so that we can type up our solution. So let's see what we've got. So it contains duplicates. So given an integer array called nums, we want to return true if any value appears at least twice in the array, and we want to return false if every element is distinct. Okay, so basically we want to just iterate through an array and check if any value appears twice. And they give us a few examples of this, where in this array, 1 is there twice, so there are duplicates, and they return true. In this example, every number is unique, so we return false. And in this one down here, there are a few sets of duplicates, so that one should return true as well. Okay, great. So I always like to start by writing some ideas down. That's a theme I'll have throughout all of these videos. So I'm going to pull up my notepad here and just write out a few things and talk about how I would go about solving this problem. So let's take the first example that they gave, 1, 2, 3, 1. And the way I'm going to think about this problem is that I want to loop through every element in this array. So we can pretend that we start out by looking at this first element, in this case, a 1. And what I can do is kind of just show this moving. So I start by looking at the first element in the array, and intuitively I want to just keep track of everything that I see. So I see a 1, so I want to note that somewhere, and then I move on to the next one, and I see a 2. I ask myself, have I seen this before? And we know that all I've seen is a 1, so no, I haven't seen a 2 yet. So we can just remember that now we've seen a 1 and we've seen a 2. So then we move on, we see a 3. We ask ourselves if we've seen that before. And based on what we remember, we've only seen a 1 and a 2, so we've not yet seen this 3. So we add that to our memory as well. So now we know that we've seen a 1, a 2, and a 3. And then we can move on to the last element of the array, which is a 1. And this time, when we ask ourselves, oh, have we seen this before? We can say yes. This 1 is a duplicate because we know that we saw that 1 before. So in this case, we would return true because there are duplicates in this list. So that's all great and hopefully makes sense. But now we need to talk about how we can represent that in code, and specifically in Python. So I'm going to talk about 2 ways that we could do that, and then decide on one that's quote unquote the best. At least how I would do it, not necessarily the best solution of all time or anything. But so solution 1, when I initially looked at this, what came to mind was using a dictionary in Python. So I'll call this the dictionary method. And what I could do with a dictionary is, let me write the list again. When I get to the first element, when I want to remember it, like I was using the metaphor in the example that I showed on the last screen, I could use a dictionary, a dict, to remember it, per se. So when I see that 1, I could go into my dictionary and say, okay, the key of 1 has a value of true. So I know that I have seen the number 1 before. And then when I move on to the 2, I can say, okay, have I seen a 2 before? I look up 2 in my dictionary and there is no 2 in the dictionary, so I know I haven't seen it. And so I can add it and say 2, that's true as well. Then I can move on to the next element, which is a 3. I look that up in my dictionary. It's not there, only 1 and 2 are. So I add it, 3, go to the next line here. That's true. And then I move on to my last element, which is a 1. And when I go to look that up in the dictionary, it appears. 1 is found. It is in the dictionary. And because it's in the dictionary, I know that I have a duplicate. So then we can return true. Now, this solution is perfectly valid, and we could write up Python code that does exactly this. But there's actually a way in which we can make it slightly easier on ourselves. And when I would go about solving this problem, I probably wouldn't go with this method and would go with a very similar but subtly different method, which I'm going to call solution 2. Now, the only difference between solution 1 and solution 2 is that I'm going to abstract my dictionary out into a set. Now, many of you have probably heard of a set before. If you haven't, a set simply means that the numbers or objects, whatever's in it, are guaranteed to all be distinct. So I'm going to say all elements distinct. Another way to say that is they're all unique. So it's basically a dictionary where you're guaranteeing that every single entry only occurs once. So it handles the duplication detection for us. And this will make more sense as we go to write the code. But basically, what can happen in a set is we consider the first element a 1. We ask, is 1 in the set? The set is currently empty. So, okay. We have not seen 1 before and we add it. Then we see a 2, we check if that's in the set. It's not, so we can go ahead and add it. Same thing with 3, it's not in the set, so we can add it. But when we get to 1, when we look inside of our set, again, we see that the 1 is already there. So there are duplicates and we can return true. Great. So again, very similar. Solution 2 is very similar to solution 1, but I personally like using a set a little bit better than a dictionary in the case where we're searching for duplicates. And so anytime that you're working with identifying duplicates, you can remember that a set might be a really good choice for that case. So now let's flip over back to NeetCode website and let's write the code that actually does this. So I'm working in Python here. And the first thing that I would want to do is create my set, which I can just call it my set. And I'll set that equal to set with a set of open and closed parentheses. Now this is how in Python you can actually declare and initialize an empty set, which is what we want here. We want to start with it empty and then add things to it as we go. So then I want to loop through the nums parameter, which is a list of integers, as we see here. So I can say for num in nums, just like that. And for each of these numbers, the first thing I want to do, like I showed in my little drawing, is that we want to see, hey, is this number already in the set? Because if it is, we know that we have a duplicate. So we can say if num in my set. So if the number that we see in the array is in my set, this means we have seen the number before. And if we've seen it before, it must be a duplicate. And so we can return true, which if we look back at the problem, we want to return true if any value appears at least twice in the array. So if there is a duplicate, we want to return true. So I show that here. And then if you recall in the drawing, I mentioned that if we check for it and it's not in the set, we need to make sure that we add it to the set. That way we can check later on if we see a duplicate of it. So if it's the first time that we're seeing a number, we need to add it to our set. So in the else case, we simply can say my set dot add num. So exactly like I mentioned in this case, where the number is not in the set, we'll fall into this else, and then we'll take my set and we'll add whatever number we're on to it. And then if we get through this entire for loop, meaning we process all of the numbers in the nums array without finding a duplicate and returning true, that means that there can only be one case, and that's that there are no duplicates. So if we process everything in nums without ever triggering this if condition, that means there weren't ever any duplicates. And so we can return false that there were none. Great, so I'm going to click run on this. And what we can see here is it has run the 3 test cases that they provided in the instructions. So if we run this one, the expected output is true and ours returns true, which is great. Case number 2, this should be false, and indeed our algorithm returns false. In this last one, there are duplicates, so expected is true and we indeed return true. And a very cool feature is that you can actually add your own test cases. So we could add this, which is all the integers between 1 and 10, and there are no duplicates there, so that one should return false. But then we could add a second test case where we add, let's say 8 again. So this one does have duplicates and should return true. So let's run these. So here we can see that case 4 should be false and our algorithm does return false. The next one, because we added the 8, should be true because there's a duplicated 8, and we get that right. So excellent. This is looking good to me. We can go ahead and click submit. And amazing. I haven't done this before, so it looks like it's been accepted. What is this showing me here? So my runtime is 451 milliseconds, which beats 62.46% of all solutions. So it looks like I've written something that's slightly better than the average, but not by a ton. Oh, this is really interesting. It looks like I wrote one of the most common solutions based on runtime, and you can get it quite a bit faster than this. And then based on memory usage, I've used quite a bit more memory than it looks like it's possible to use. I've not reached the 50th percentile. Oh, this is really interesting. So you can click on something else and see a sample solution that's smaller. Like this one used hash tables. This is super interesting. And I could play around all day with looking at this, but my goal is not to write the fastest or most efficient code. It's just to explain the techniques that I find intuitive and that I would do if I was in the interview. So yeah, great. So that's a wrap for the duplicates, LeetCode or NeetCode question, and I will be back soon with the second code the second program in the NeetCode sequence.